Welcome to Ask and Learn.
Okay, so this problem asks us to generate a variety of these fairly simple final products, starting with this isopropanol unit. The way I recommend approaching these types of problems is to recognize where the carbons from your starting material are ending up in your product. For the first case, I actually think that this isopropanol unit is these 3 carbons on the bottom of this product. What that would mean is these 3 carbons have to be a nucleophile to attack this electrophilic carbon here. So knowing that, we can design a synthetic route in which we first use HBr to generate this isopropyl bromide, followed by generation of this Grignard reagent. And finally, we can use this methylaldehyde, followed by an acidic workup to get to your product A. For product B, you'll recognize a CH2-CH2 oxygen motif that is commonly seen from the ring opening of an epoxide. So now that we have this isopropyl Grignard, we can simply change the electrophile to an epoxide, followed by an acidic workup to get to this product. For problem C, you'll recognize that our isopropyl unit is still containing our oxygen, but now we have this cyclohexyl unit that has a carbon-carbon bond formation. That carbon-carbon bond formation could come from the carbonyl attack of a cyclohexyl Grignard. So first we would need to oxidize up our isopropyl alcohol into a ketone using something like PCC or Jones reagent. Next, you can simply add in the cyclohexyl Grignard, followed by an acidic workup to get to your final product. For D, you'll recognize we have the same carbon-carbon bond formation, but the alcohol is actually on the other side. So we could actually come from the isopropyl Grignard, which we've already discussed how we can generate, and then simply react with this ketone, followed by an acidic workup to get to the final product. In the last case, you'll notice our isopropyl subunit is most likely here, but we cannot just use the straight Grignard with the other side of this molecule because we have another electrophilic source in this ketone here. So if we were to use this Grignard, we could first attack something like this and use 2 equivalents of our starting material. The first equivalent would actually just deprotonate the alcohol. The second equivalent would actually attack and do an SN2 reaction at this point. After an acidic workup, we'll access this alcohol, in which now we can use PCC or some other oxidizing reagent to get to our final product.